Hello everyone, and today we'll be seeing one of the problem from Geeks or Geeks. The problem says find the H index. It mentions that we are given an integer array of citations, and within this, a citation of I is a number of citations which a researcher received for the ith paper. So this belongs that for 0th paper I have received 3 citations, and first paper is 0 citations, and so on. Now, what the H index is? So, H index is the largest value such that the researcher has at least H papers that have at least H citations. So, which means let me jot it down over here. It says that H papers with at least H citations. Now, here the important point is H is constant with the number of papers and number of citations. Now when you see over here, it's 3530. So the number of citations is 3. How come it is possible? Then if you're going to ask, so then let's start with 0. Are there 0 papers with 0 citations? Yes, there are. So 0 can be a possibility. I'm not saying that it is the possibility, because it is the H index, because H index means the largest number, so can be H. So let's say about 1. So can 1 be H? Yes, it can be H, because we have let's say paper I, paper 0 or 2 or 3, which has 353 citations, so which is greater than 1. Then in that case 1 can be H. So well, can 2 be H? Yes, because 3 and 3 are qualified. Okay, let's say whether 3 can be. Yes, 3, 3 and 5. And let's say whether 4 can be. So it says no, because first of all we'll take any 4 letters or 4 papers, then none of the 4 papers has greater than 4 citations. Only one has citation number which is greater than 4, but that's not qualified, so it can not be. But mind it that searching this way can be very tedious, and it can go till O of n citations of n into n. Wait, why? Because for each value of n we are iterating n times, so this can go up to the size of an array, which is not very good. Can we improve this? The answer is obviously yes. So you see, what was the problem with earlier approach? With earlier approach we used to check one by one, and we used to start from lowest to highest. We can avoid that, obviously. We can go directly from the highest and check this, check that. But how do we come to know whether it is highest or not? So obviously we need to sort it. Now sorting makes sense. Let me format it once. We need to sort it and then check if we have at least that number of paper and that number of citations. So this is step 1, and this obviously is step 2. Within 2 steps we have came to know. Within step 2 only we can return the value. So bear with me, I know it might be confusing, but it's very simple problem if you look it closely. Ultimately we return the number of citations if we don't found any. So ultimately, let's go ahead and write a code. So I'll check if a is null or a dot length is equal to 0, return 0 in that case, because there doesn't exist any h index for this. But if there is an array, let's sort it out. So sort the array a, and obviously this will sort in the sorting in ascending order. And now what we wanted to do is check for int I is equal to 0, I is less than a dot length I plus plus. Now we here have I plus 1 represents the paper, and last, or I must say maximum, I plus 1th paper is a of a dot length minus I minus 1. Think for a while how this is possible, because once I is 0, then the maximum would be 0. Obviously we can sort it out within the reverse order, but since it's an integer, primitive integer array, there is no available known function for this. If it would be an integer array of boxed class, wrapper class, then we can do that operation, but not here. So we are going in this slightly complicated way, not so complicated, but slightly, yeah, slightly bit too exaggerative. So if I'm saying that, hey, if my paper is I plus 1, which is, let's say, greater than the maximum element, which is over here, then it's not possible. That means if we have ith paper and at least ith value, it's valid, but not the opposite. In the opposite way, we'll just go ahead and return the I, which is just one less than this. So if we are upon h index as 4, and we find out that, hey, 4 cannot be the reason, and since we return 3, the same case follows. And ultimately, if we see none of the cases have triggered the return statement, that means the citation number is very, very high. Consider it like this: 9999, 9999, and 9999, something like this. So in this case, even the citation number is so huge, but the h index is still 3, which is nothing but the length of an array. Obviously, you can get the point that h index can never ever go beyond the number of research papers, which defines its definition as well. It might be so quite complicated, given the fact that, hey, okay, that's great. Given the fact that h index might be very new, but just give it a try and go through this definition if you didn't understood it well. I'll go ahead and submit this one. And by the way, let's check within this topic converts. Okay, it's not array, it arrays. Let's submit this now. So this topic basically contains your understanding of arrays and sorting, and the time complexity of this algorithm is obviously defined by the sorting algorithm, which is n log n. As you can see, we have submitted it and it has been passed rest of test cases. So for more such content, do click the video on your right, and I'll see you in the next one.